In this video, we're going to evaluate expressions. So recall from Unit 1 that evaluating means to calculate, and we've already practiced evaluating some expressions in Unit 1, but now we're going to practice evaluating more complex expressions. We also learned that in arithmetic, when you're asked to evaluate, basically it's the same as perform the indicated operations or simplify. But in algebra, when you're asked to evaluate, it means that you're given a specific value for x or for whatever variable you're given, and that you can replace the variable with the given number, and then the result is just performing the operations like you would do in arithmetic. So it's basically replacing the variable for a specific value. Some people say you're plugging in a number for x, okay, and then following the order of operations. Okay. In this section, we will evaluate a few of our expressions from the last section, actually the last video, for a given value of a variable. And specifically, we're going to evaluate both the original expression and the simplified expression to verify the expressions are in fact equivalent. So, looking at our last video, when we simplified, say, perhaps this expression, every single line of these expressions are equivalent until we get to the most simple version of this expression. Now, since they should each be equivalent, okay, that means for any value of x that I put in this expression, it should equal, when we compute, the answer when I evaluate this expression given that same number. Okay, so it must be true for every value of x to officially verify that they are equivalent expressions, but we're just going to use one test value and practice equivalent expressions. So let's look at our first example. So we were given this original expression, we simplified it, and this was our result. So this is the most simple version of this expression. And now we're going to practice evaluating this. So basically I'm going to start by write the entire expression, but replace x with 2. So we have 3 times 2 minus 5 plus 7. Okay. Now notice we have all numbers here, and this is a problem you would see in arithmetic class. So we're just going to evaluate this using the order of operations. First we do parentheses. Okay, we could distribute, but hey, we can subtract these, so we might as well do that. It's easier. 2 minus 5 is negative 3. Now we have multiplication and addition. Multiplication comes first. 3 times negative 3 is negative 9. And negative 9 plus 7 is negative 2. Now if these expressions truly are equivalent, okay, when I replace x with 2 in this expression, I should also get negative 2. So let's see if that happens. So I'm going to replace the x with a 2. I'm going to put that in parentheses. And in general, whenever you're replacing a variable with a number, put it in parentheses. Sometimes it won't be necessary, but notice here, by putting it in parentheses, we're showing the juxtaposition of 3 and 2, which implies multiplication. You could also write 3 times 2 here, but it's good practice just to, when you replace a value, put it in parentheses. Okay, we have multiplication and subtraction, so we do multiplication first, and 6 minus 8 is in fact negative 2. Okay, so these two correspond. Again, that doesn't prove they're equivalent expressions, but based on the idea that we created equivalent expressions, this is the result we'd expect to see. Let's look at the next one. Evaluate 3x minus the product of 1/2 and the sum of 4x and 4 plus 6 when x equals 3. Okay, so this one looks kind of like a bear, and there's a simple version, so you could see why we like to simplify. But let's practice evaluating this when x equals 3. So notice there's more than one place we'll have to replace x with 3. So we have 3 times 3 minus 1/2 in parentheses. Now I have 4 times 3 plus 4 plus 6. So that was my first step, replace x with 3. Now I need to follow the order of operations. So first I need to do parentheses, which is right here. Let's highlight that. And in the parentheses, notice there's two operations, multiplication and addition. Okay, so I'm just going to write above this, 4 times 3 is 12. Okay, that's the operation we would do first. And the next operation is addition. So again, we could do these line by line, but there's going to be a lot of operations. So now that you're more adept at performing the order of operations, sometimes you can take little shortcuts. 3 times 3 minus 1/2. Now 12 plus 4 is 16, plus 6. Notice I'm being careful to include all the other components as I move along making equivalent arithmetic expressions. So now let's see what we have. We have multiplication, subtraction, multiplication, addition. We need to do multiplication first. Okay. And here we have a multiplication right here and right here. So I'm going to perform them left to right. I'm going to do this one first and then this one, but I'm going to write this in one line. Okay, so instead of, again, first doing 3 times 3, then writing 9 here, and writing this whole part, I'm going to perform this operation and this operation because they're both multiplication, so I'm still following the order of operations. 1/2 times 16, or 1/2 of 16, is 8. Then we have plus 6. Okay. And now we're left with subtraction and addition, so we can just work from left to right. 9 minus 8 is 1, and we'll write that 1 plus 6, and 1 plus 6 is 7. Okay. And after this video, I'm going to make a brief video showing you how to check these on your calculator. Okay. Now here, let's check the equivalent expression, x plus 4 when x equals 3. Replace x with 3, and 3 plus 4 is 7. Okay, so it's some work to simplify expressions like this into a form like this, but if you needed to evaluate this for, 5 or 6 numbers, or with fractions or decimals, I think you see that this would be the nicer expression to work with. Let's look at the next one. Okay. So here, I'm not going to read this. We could, but why torture ourselves? We have a really long expression that we need to evaluate when x equals -1. This was the simplified expression. And before we start, I want to remind you that, again, remember I said we're always going to replace our variables in parentheses. And when we have something like x squared, and we replace x with -1, you need to put the -1 in parentheses, and here's why. -1 squared means 2 factors of -1. -1 times -1, well, a negative times a negative is a positive. Now, you may remember from a previous course, so this is what this equals, replacing x with -1. If you have an expression that looks like this is the opposite of 1 squared. Okay, so here, this opposite or negative sign is not being squared because we perform exponents first. Okay, and the exponent is just applying to the 1. So this means the opposite of 1 times 1, which is -1. Okay, so here's where you really need to be careful. You need to remember this rule. People forget it frequently, but also this is another reason why you should always put, when you replace your variable, put it in parentheses. If you put this expression in parentheses, the calculator will tell you it equals -1 if you leave out the parentheses, okay, which it in fact does. You'll think your answer is right because, hey, the calculator told you so, but it's actually incorrect. X squared is saying x times x. If x is -1, it's -1 times -1 is +1. Okay, so that being said, let's go through this expression. So I have -1 squared plus 2 times -1 minus 3 minus negative 2 times negative 1 squared plus 4 times negative 1 minus 7. Okay, so this is a lot to work with. It's not going to be that bad though, I promise. Okay, so first, notice these are parentheses, but they're not operations that need to be performed in the parentheses. However, here, there are some operations to be performed. Okay, so we're going to perform all of the operations in here first. According to the order of operations, we're going to do exponents, then multiplication, and then the addition or subtraction. Now, I know you're not going to like this, but every step you need to write. We're making equivalent expressions, so you need to continue to write this first part as we're working with this second part. Okay. So first I'm going to do the exponent. Negative 1 squared, we said, is 1. Negative 2 times 1. Okay. And again, at this point, since you're in algebra, let's save ourselves a little time. Here we have multiplication and multiplication. Let's write our results above it and then do our subtraction. So negative 2 times 1 is negative 2. 4 times negative 1 is negative 4. And that's minus 7. So now, let's copy again. Negative 1 squared plus 2 times negative 1 minus 3 minus. Now we have negative 2 plus negative 4 minus 7. Negative 2 plus negative 4 is negative 6. Negative 6 minus 7 is negative 13. Okay. And again, if I'm doing this too quickly, I know sometimes you forget things. Do this on the side by hand. Okay, try not to show too much work in here. You want to do some side work up here, and then verify it on your calculator. Okay. So now what do we have? We have an exponent, addition, multiplication, subtraction, subtraction. Let's do the exponent first. Negative 1 squared is 1. And while I'm here, we're subtracting a negative, and that's the same as adding a positive. So since this is at the end, that's not going to matter. So I'm just going to put plus 13. We have one last multiplication to do. Let's do this right above it. So 2 times negative 1 is negative 2. And now we can go straight to our addition and subtraction. Okay. Again, this is 1, 2, 3 operations. We could show this in 3 steps. Okay. But we're going to start to do these in one string just to save ourselves showing some work. Okay. So it's okay to do that when you're adding just a bunch of them. So we have 1 plus negative 2 is negative 1. Negative 1 minus 3 is negative 4. Negative 4 plus 13 is 9. Okay. So just to show you how I did that again, we had negative 1 minus 3 plus 13. That was that sum. Then negative 1 minus 3 is negative 4 plus 13. And negative 4 plus 13 is 9. And again, computations like this, you really want to do them on the side. Try not to do them too much in your work because you can end up doing those running equal signs where you write something that's not equivalent. Okay, so our result is 9. Now let's do it in the simplified expression, which I think you can see is going to be much easier. So 3 times negative 1 squared minus 2 times negative 1 plus 4. We'll perform the exponent first. Negative 1 squared is 1. Okay. Now I'm going to perform multiplication. There's 2 multiplications, a subtraction and addition. I'm going to perform multiplication from left to right. First I'll do the 3 times 1. And 2 times negative 1 is negative 2. Okay. So again, I did the 2 multiplications in one step. I just made sure I did them from left to right. Okay. Now let's change this subtracting a negative to adding a positive. So this is 3 plus 2 plus 4. And 3 plus 2 is 5, plus 4 is 9. And our results do check. Okay, so the calculator problem that will be after this in your media lesson, it won't be in your media lesson packet, but please watch it anyway.